Good afternoon, everyone, and welcome to the first in a series of what I'm calling Net Talks, where I want to get together with you every now and then here on my YouTube channel and share a specific networking technology. And I want to do that in about 35 or about 30 to 45 minutes. That's my goal. And for our first topic, for our very first Net Talk, we're going to be addressing GRE over IPsec tunneling, setting up a GRE over IPsec VPN. This can be really useful for you if you're going after your any of your the security certifications in Cisco's track. And the reason I hesitated, I was thinking, I'm not sure how many people are going after it yet, but this is one of the topics on the new Encore exam coming out next year, next February the 24th. That's going to be like the core exam that's going to be required for your CCNP enterprise certification. It's also going to be the core exam it's going to be the equivalent of the written exam for the new CCIE Enterprise Infrastructure Lab. So yeah, pretty important exam, and this is one of the topics on it, so I thought it would serve those people as well as anybody in the security track. And I was looking in the chat here before we got started, people talking about what they're doing right now in terms of certification. I'm just super curious. If you wouldn't mind sharing with me, can you tell me, where are you right now in your certification journey? Are you in the camp that I need to get this specific certification done by February the 24th? And if so, go ahead and put that in the YouTube chat and tell me what that certification is. Or if you're going ahead and starting to study for some of the new certs, I'd love to know that as well. Where are you right now? Or maybe you're here for some real world knowledge, or maybe you just saw that Kevin's going live and you wanted to see what was up with that. So let's take a look at and see what people are. Let's see. Oh, somebody says my sound is low. Let me see if I can adjust that. All right. Give me some feedback if you would. Is my sound better now? Trying a new system, you might notice that the resolution has dramatically improved over previous live streams. I'm actually streaming in 1080p at 30 frames per second. So I wasn't able to do that previously, but I am now. And hopefully it looks really good. Everybody says, yeah, the sound is much better now. Thanks for that feedback. You're sort of my test subjects because I haven't used this particular software before. But yeah, people are saying that. Let's see, passed ICND 1 last week, preparing for ICND 2 now, scheduled at the end of December. I'm planning to pass switch and route before February. Okay, awesome. I just need to do my T-shoot exam, and then I'm done with my CCNP. Awesome. So it sounds like a lot of people are going for the existing certs before the new ones come along. And right now, I'm going to leave this on my YouTube channel for a long time, but let's see, today is November the 26th. And that's 2019. So yeah, for most of my students, that's enough time to get in another exam, another NP level exam or another NA level exam. So yeah, I think that's great. In fact, let's get to it today. Let's talk about, so we can keep in our 30 to 45 minute timeline, let's talk about GRE over IPsec. And just so I don't obscure anything, let me get my picture off of the screen here. And let's take a look at the agenda of exactly what we're going to be talking about today. We're going to begin by talking about, well, right now we're in the midst of the introduction, but we're going to talk about why we need both. Why do we need both GRE and IPsec tunneling? Couldn't we just use one or the other? We'll see that they sort of depend on one another, and we'll take a look at how to configure a GRE over IPsec tunnel. We'll do that for you in a live interface. I think you'll really enjoy that, and we'll spend some time doing Q&A at the end. But let's begin by just introducing myself for some of you that stumbled upon the YouTube channel here. You have no clue who I am. Here's my super quick bio. I won't belabor this, but my super quick bio is, yeah, my name's Kevin Wallace. I got a couple of CCIEs. I'm now an emeritus designation. I've been in CCA since 2001, and my CCAs are in collaboration route switch. Been working with this stuff from the very first Cisco router, the old AGS Plus router back in 1989. Taught courses with Cisco Learning Partners for about 14 years. Was one of 5 network designers down at Walt Disney World in Florida, and wrote a bunch of books for Cisco Press, done a lot of training videos for them. I've been a distinguished speaker a couple of times at Cisco Live. Bottom line is, I love this stuff, and I cannot wait to share today's content with you. So let's get right into it. First of all, I said we probably don't want to use just GRE or IPsec independently. We want to use them together. Why is that? Well, I remember when I first got into networking back in the 90s, where we were interconnecting WAN connections. We were connecting remote sites to maybe a central site. And back in those days, we had to use something like frame relay circuits. That was more popular. ATM, we also had some lease line circuits, but it was expensive. If you wanted to interconnect a couple of devices or a couple of sites over the internet, you're gonna pay some money for that. But these days, we've got the internet. We've got high-speed internet connections. In my home, I've got gig fiber. It's unreal that I have gig download and upload in a home environment. That would be unheard of just a few years ago. So now we've got these high-speed internet resources available to us easily. So what can we do with that? Well, we can just use the internet to connect these remote offices. But I know your concern. The concern is, well, even though we can use common broadband technologies, is it going to be secure? That's an untrusted network, isn't it? The internet's scary. There are people on the internet that are bad actors that might do bad stuff with our data. But if we did use the internet, that would be so cool because it would be transparent to the end devices, and we can protect all of our traffic using a VPN, a virtual private network. It gives us privacy virtually over this public communications network. And we can have routers at each of our sites, and they can do the heavy lifting of the encryption and the decryption, so it's completely transparent to the end users. And yeah, we can get really high-speed connectivity between our sites if the internet in that location is available at high speed, and we can do it securely. So let's talk about some of the VPN protocols that make that happen. One protocol that we'll probably turn to is called GRE, Generic Routing Encapsulation. It is super flexible. It can encrypt it can encapsulate and put inside of this virtual tunnel. It can encapsulate just about anything you can imagine. It'll encapsulate broadcast, unicast, multicast. If you had Apple Talk or Novell IPX, that would work as well. It will encapsulate just about anything you can think of. There's a big downside though. You ready? Hate to break it to you. It doesn't do security at all. So that doesn't really meet our needs, does it? We said we wanted to be able to communicate securely over the internet, and I said, well, here's a way to make these two sites look like they're adjacent. I mean, they look like they're layer 2 adjacent. They can form OSPF neighborships, but it's not secure. Okay, well, let's turn to something that is secure. What about IPsec, which is short for IP security, and as the name implies, it is super secure. Let's take a look at some of the characteristics of IPsec. I said it was secure. Here's what I mean by that. It can do confidentiality. And by that I mean it's going to give us encryption. It can run very robust encryption standards so that if some bad person intercepted our data on the way to the destination, they wouldn't be able to interpret it because it's all scrambled up, and they would not be able to descramble it. It also is going to give us integrity to make sure data is not modified in transit. That's using a technology called hashing. Now, a lot of people get this really confused. They'll look at a hash result called a hash digest, and they'll say, oh yeah, that's the encrypted password. Actually, it's not. It's like a fingerprint. One of the, it's not the strongest, but just one of the popular hashing algorithms that have been around for a while is called MD5, Message Digest 5. And you could take a 3-letter word like cat, and you would run it through the MD5 hashing algorithm, and the output would be 128 bits. Okay. What if I took a big book, like I took my big route official cert guide book that I did for Cisco Press? I think that's got like 700 pages in it or something. And I ran that through the MD5 algorithm. What would it give me? 128 bits. Well, obviously, there's no way to extract a 700-page book from only 128 bits. So it's not an encryption. It's a fingerprint. We generate these 128 bits based on this algorithm that we run on the data string. However big the data string is, it doesn't matter. The hash result is going to be 128 bits, and we're going to do that calculation at each end of the communication. And if they agree, if the hashes are the same, that's a good indication that the data has not been modified in transit. We can also authenticate the other side, so we're talking to the person we think we're talking to. We can do that with either a pre-shared key, where we configure each end. That's what we're going to do today in our demonstration. Or we could use digital certificates with digital signatures. And it also defends against replay attacks. You might have somebody that captures traffic on the network. They're not able to read it right now, but they captured the packets that were being exchanged when somebody successfully logged on. And they thought, oh, these are the packets that will get me logged on. I'll come back later and I'll play them back, and that'll get me logged on. No, not with IPsec. It essentially applies serial numbers to those packets. So if you come back later and you try to play them out of order, it's going to say, no, those aren't happening now. This is a replay attack, and we're going to reject that. Now, the downside to IPsec, I've got bad news here as well. As great as it is when it comes to security, its big limitation is it only has the ability to encapsulate unicast IP packets. What about broadcast? I mean, I might need to ARP. What about multicast? I mean, OSPF version 2 and 3 and EIGRP and even RIP version 2 and RIP-NG, they all use multicast for routing protocols. We use multicast for other things as well. It's not going to send multicast traffic, so it doesn't carry everything we want. We'll address that. And something that'll be important to our configuration today, I want you to understand that there are two different modes that IPsec can run in. One mode is called transport mode. This is where the packets are going to not replace the original header. We'll use the packet's header. We'll just encapsulate and encrypt the payload. Or we could use tunnel mode. That encapsulates absolutely everything. And when we're setting up an IPsec tunnel, it's really a two-step process. The first step I kind of compare to, I don't know if you've seen the old TV show Get Smart, or a few years ago they did a movie with Steve Carell. It was hilarious, by the way. I highly recommend it. But whether you watch the movie or the TV show, you might remember the scene where Max is trying to talk to the chief and he wants to do it in private. So they lower the cone of silence. So the cone of silence comes down over Max and the chief. It never really works right in the movie or the TV show, but the idea is that gives them a secure communication channel where they can discuss plans. Well, that's kind of what's happening here in the first step of setting up an IPsec tunnel. You might want to take some notes on this. The first step is the creation of what is called an IKE Phase 1 tunnel. It has another name. It's also known as an ISAKMP tunnel. IKE, that's Internet Key Exchange, and ISAKMP, that's Internet Security. I won't read it. It's there on the screen for you. But those are synonymous. We're going to set up an IKE Phase 1 tunnel, and it's within the protection of that IKE Phase 1 tunnel that we're going to... It's within the protection of the IKE Phase 1 tunnel that we're going to negotiate the parameters for the IKE Phase 2 tunnel, also known as the IPsec tunnel. So here's the dilemma we have, folks. We've got one protocol that we love for its flexibility, GRE. It'll encapsulate everything practically, but it does zero security. And then we have IPsec, which we love for its security abilities, but it will only encapsulate unicast IP traffic. We would really like to have some third option where it's the best of both worlds. What if we did this, though? What if we combine the two? Follow me on this. What if I took everything. I don't care if it's unicast, multicast, broadcast, Apple Talk, IPX, it doesn't matter. DECnet, whatever we're sending, we're going to encapsulate that inside of a GRE tunnel, which takes everything. When we encapsulate it inside of a GRE packet, think about this for a second. What is a GRE packet? A GRE packet is a unicast IP packet. Do you see where I'm going with this? Once we put everything into GRE, it's now a series of unicast packets. Those can then be sent inside of an IPsec tunnel where they can be encrypted. We're working at teamwork makes the dream work. Well, that's what we're doing here. We're teaming up GRE with IPsec, and we're able to put everything into GRE to make everything an IP unicast packet, and then we'll take those IP unicast packets and send them securely inside of an IPsec tunnel. And I want to take you out to a live interface now and show you exactly how to set that up. Before we do that, here's the topology that we're going to be working on. We're going to be working on this topology where we've got 4 routers. Now, follow me on this. We're pretending that our company has a couple of sites. One of our sites is using router R1. Another site is using router R4. And between our 2 sites, between R1 and R4, we're going through a service provider. And coincidentally, they numbered their routers R2 and R3. Bottom line is, we have zero control over those routers. We cannot control R2 or R3 because they belong to the service provider. We want to create a tunnel across them, and we want to encapsulate traffic going between these 2 different routers. And the first thing we're going to do is we're going to set up a GRE tunnel. And a GRE tunnel is going to be using a virtual interface. It's going to be like a tunnel interface. I'm going to number it probably tunnel 1. And we'll give an IP address for each end of that tunnel. Obviously part of the same subnet. It's part of the same network segment. And we'll make sure that works. Once we get that unsecured tunnel set up, then we're going to configure IPsec. Now, when you set up IPsec, you don't have to send everything inside of that encrypted tunnel. You can say what traffic is deserving of this high security treatment. Maybe we don't need to send everything securely. Let's ease the bandwidth, processor demand on our routers. But in our case, we're going to say, nope. What's interesting, what is qualified to be encrypted is all of our GRE traffic. So we're going to make our GRE traffic our interesting traffic. And then we're going to send it across that IPsec tunnel. And then we're going to verify it. So let's go out to our topology here and our routers. And let's get this set up. Now, we'll go through this nice and slow if you want to take some notes on this. Again, step 1 is we want to configure a GRE tunnel between, we're going to configure a GRE tunnel between R1 and R4. Those are the only routers that are under our control. We cannot control R2 or R3. Somebody says, I'm taking notes. I'm going to purchase the cone of silence for the next meeting. That's funny. All right, let's do a GRE configuration on R1. Now, like I said, we're going to create just a virtual tunnel interface. I'm going to say interface tunnel 1. And I need to give it an IP address. And this is its own network segment. So it's not like, okay, which of my router interfaces am I using for this network? This is a separate network. This is like a brand new router interface. It's going to have its own network segment on it. And based on that topology you see on the screen, I'm going to give it an IP address of 192, say IP address, 192.168.0.1, and we've got a 30-bit subnet mask, which is 255.255.252. And now I need to say, who is the source of my tunnel and who is the destination of my tunnel? Well, I'm going out of that bottom interface on R1. I'm going out of gigabit 0/1. So I'm going to say my tunnel source is gigabit 0/1. Who's my destination? Well, I'm going into that top interface on R4. It's got an IP address of 198.51.100.2. So I'll say my tunnel Destination is an IP address of 198.51.100.2. And we're done with our GRE configuration on R1. Let's move over to R4 because we're not allowed to touch R2 or R3. And we'll do sort of a mirror configuration here. We'll create this virtual tunnel interface. By the way, I use tunnel 1 in both cases. Those don't have to match. That's not information that's exchanged, and it's not like an EIGRP autonomous system. It doesn't have to match. I just like to use one because it's easy to remember. And I'll give my IP address at the bottom of that tunnel according to our topology, an IP address of 192.168.0.2. Again, we got a 30-bit subnet mask. And I'll say who's the source and who's the destination. It's going to be the reverse. From the perspective of R4, my local interface, I'll say tunnel source, my top interface going up towards R1, that's going to be gigabit 0/1, and the tunnel destination is going to be that ingress interface on R1, which is 192.0.2.1. I'm just double checking that because that would break everything if I typed in an incorrect IP address, but I think that looks right. And we're done. We now have a tunnel set up between R1 and R4. Let's verify that though. If I do a show IP interface brief, it shows that this tunnel interface is in the up state. We also saw, look at this, we had an OSPF adjacency change because R1 and R4 now appear to be layer 2 adjacent to one another. I think we formed an OSPF neighborship. Let's do a show IP OSPF neighbor command. Look at that. Not only is R4 a member or a neighbor with R3, which it's directly connected to, it's also a neighbor with R1, which it's virtually directly connected to. And I can do a show interface tunnel 1, and we can see information about this. We see that it looks like it's operating at, well, we would probably want to go in and change the bandwidth possibly. We don't want to operate at 100 kilobits per second probably, but we could certainly go in with the bandwidth command and alter that setting. But that's something good to check. Now, trying to think, yeah, let's do one other verification command. Let's do a trace route up to that bottom interface on R1. Does it show that we're going through R3 and then R2 and then into R1? Or does it just show we're going directly into R1? And when I say R1's interface, I'm talking about the other side of the tunnel interface on R1. Let's do a trace route to 192.168.0.1. Look at that. It was one hop. Even though I'm physically traveling through R3, R2, and then into R1 to get there, it said, nope, we're adjacent to it. It's just one hop. We've now configured and verified our GRE tunnel. Let's now turn to the slightly more challenging IPsec configuration. Remember we said that IPsec is set up in two phases. There's IC phase 1, also known as ISAKMP, and there's IC phase 2, also known as IPsec. Let's do IC phase 1 right now. And I'll go back to R1. We'll just keep doing things in the same order. But on R1, I'm going to create my IC phase 1 policy. I'm going to say crypto. Let's use some context-sensitive help here. I'm going to say crypto ISAKMP, this is for IC phase 1, crypto ISAKMP policy, and I can give a priority. Now, what this is all about is the two sides of this tunnel need to agree on what authentication, what encryption we're going to be using. And I can create a policy that will say, all right, this policy uses this encryption and this authentication. Can you do that? Do you have a policy that matches this? And the other side might say, no, I don't have a policy that matches that exactly. I've got this other policy. So we keep comparing policies. We could have a bunch of policies on one side, but we have to have a matching set of parameters in some policy on each end of this tunnel. Now, for simplicity's sake, I'm just going to make our two policies match. I'll create the same basic policy on each router. But that's the reason we're giving this 10. I'm saying I'm going to prefer the 10, but if that doesn't work, I'll go to policy 20. As an example, and I'll see if the other side will support that. This is just for that negotiation. Now, what am I going to configure here in policy with a priority of 10? Well, let's configure the encryption. I've got different encryption options. We've got triple DES, AES, and DES. Don't even think about using DES. It is super insecure. It's been around since the 70s. There are vulnerabilities all over the place. Triple DES is better, but the flagship is AES, the Advanced Encryption Standard. That's what I'm going to select, and we can select how many keys we're going to have here. I'm just going to press enter and take the default. And I'm going to say the authentication. Do I want to use a digital certificate, or do I want to use a pre-shared key? Just to make it simple so we don't have to set up a digital certificate, I'll just configure the same key on both routers. I'll say we'll use a pre-share key, and we say, how are we going to exchange our key? We're going to use a Diffie-Hellman group, and the higher the group number, the more secure it is. It gets into modular math, which is kind of fun to play with, but way beyond the scope of what we need to talk about today. I'll just say group 2. That's just what I've been using for years. I typically say Diffie-Hellman group 2. And we're done with that policy, but the policy said, okay, you're going to be using a pre-shared key. I need to set that up now. I need to say, here's the pre-shared key on my side for my IPsec policy, and I'll do the same thing on the other side. So here's how I do that. I'm going to say crypto IPsec key, and I'll just call this Kevin's key. And I can specify the address with the peer I'm going to exchange keys with. Now, in the real world, you might want to be very specific and make sure you get the far end router just right. But sometimes you might want to leave it open if it could be multiple routers trying to connect to you. Here in this lab environment, I'll just leave it open to any peer that has a matching key. So I'll just give all zeros, 0.0.0.0, 0.0.0.0. And now that we've specified the parameters for IKE Phase 1, it's time to create a transform set for IKE Phase 2. The transform set, that's a collection, again, of encryption and hashing algorithms, and we have to find a matching transform set on the other side, kind of like the IPsec policy. Here's how we do that. I'm going to say crypto IPsec transform set, and I'm going to give it a name of just my company name of KW Train. And let's see what options we're given here. We're given some encapsulation options. And I'm going to use AES. Now, this ESP and AH, this stands for Authentication Header. This stands for Encapsulating Security Payload. ESP is better than AH, without getting into all the details of why. I'm going to say ESP-AES for Advanced Encryption Standard. That's typically what I do. Now I'm going to say, what is my hashing algorithm to make sure that data's not been modified in transit? Here are my options. I'm going to use Encapsulating Security Payload SHA, which is better than MD5, by the way, and I'll say HMAC. Now, what HMAC is, remember I said that with hashing, I said the router at each end is going to run this encryption, or excuse me, this hashing algorithm on a string of data, and if they both come up with the same result, then the string has not been modified in transit. Little hole in that logic right there. What if somebody intercepted that in the middle during the transmission, and they altered it, and they recalculated the hash value, and they sent that recalculated hash value onto the recipient? They look at the modified data, they run the hashing algorithm. Sure enough, it matches the, unbeknownst to them, the modified hash result, and they say, nope, this has not been altered. Well, HMAC adds another level of security there. It adds a secret key that the man in the middle would not know, so we would be protected. We also talked about tunnel mode versus transport mode earlier. We could use either one. I'm just going to use transport mode for no particular reason. And now I need to say what traffic is qualified to go over the IPsec tunnel. What do we consider to be interesting traffic? And I'm going to define that interesting traffic using an access list. I'll say IP access-list extended because I want to specify a specific protocol, GRE. I'll say I'm going to name it GRE in IPsec. That's going to be the name of my named access control list. And I'm going to permit GRE traffic from anywhere to anywhere. Okay, who's going to go in that? All the traffic going over that tunnel is going to be interesting traffic because it's all gone inside of that GRE tunnel. So now everybody that we're sending over the IPsec tunnel is going to be all the GRE traffic, which includes everybody. So that's where we're kind of merging these two together. And now the next step is we create what is called a crypto map. A crypto map, that's the connective tissue that sort of bonds everything together that we've been configuring. It ties together the interesting traffic, the transform set, and we point to the IP address of our peer. So I'm going to say crypto map, and I'll give it a name of VPN, really creative. I'll give it a sequence number, and I'll say IPsec ISAKMP. That's the way we typically set up an IPsec tunnel. We're using IPsec in conjunction with ISAKMP. In other words, ISAKMP is first, IK phase 1, IPsec is second, IK phase 2. Great. Now, notice it says this is going to be disabled until we point to a peer and we say what traffic is interesting. Okay, let's do that. I'll say match address and the name of my access control list. I want to make sure I type it just right. So to avoid a typo, I'm going to copy paste that. And I'll say the transform set that I'm using that we created, I called KW train. And my peer, if you look at the topology, is going to be that 198.51.100.2 IP address. That's the ingress interface on the top of R1. And the final thing we do is we apply this to the interface we're using to send our GRE packets, which on this router is gigabit 0/1. So we've created the crypto map that tied everything together. Now I say I'm applying that crypto map to traffic exiting gigabit 0/1. So let's go into interface configuration mode for gigabit 0/1, and I'll say crypto map, and we call it VPN. Now we've given half of the configuration, and I know you're thinking, do we have to wait for 10 minutes for Kevin to type all that in again? No, you don't, because I put the mirrored configuration that we need to give in R4. I put that in a text document so I can just paste it in. The only thing that's different is I'm pointing to R1's IP address. I guess that's it. That's really the only difference. It's a matching configuration, so nothing new here. Oh, I probably need to go into global configuration mode for that. That will be helpful. And then let me paste that. Let's see, what am I doing? Let me try copying this again. Oh, I need to go into global config. That's what I neglected to do. Now let's paste in the configuration. That's better. And we'll give it a second for it to bring up the tunnel. In fact, let's send some traffic over. Look at that. We just had an OSPF neighborship form over the tunnel again. All right. Let's send some traffic. I'm going to ping the loopback interface on R1. I'm going to ping 1.1.1.1. See if it gets through. It did. Let me send a little bit more traffic. Just trying to generate some traffic to show up in our verification commands. If I want to see the state of my IK phase 1 tunnel, I can do a show crypto ISAKMP SA, and that stands for Security Association. And it says we're active. That's the IK phase 1 tunnel. What about the IK phase 2 tunnel? Well, instead of show crypto ISAKMP, it show crypto IPsec SA. And we can actually see packet counts. It says we've encapsulated these many packets, we've decapsulated this many packets. This is giving us confirmation that traffic really is flowing over our IPsec tunnel. And the only traffic that we considered interesting for the IPsec tunnel was our GRE traffic. That means we are now, traffic we're sending from R1 to R4 is going over that GRE tunnel. And yeah, show IP-OSPF neighbors. Yeah, we can set things up such that we're going to be using that tunnel to go from R1 to R4, so we could send traffic securely across the internet. Wow. That, my friends, is GRE over IPsec. And my goal was to cover all that in about 30 to 45 minutes, and it looks like we covered it in about 35 minutes.